So in Chapter 3, this is called Self-Serve with FME Server. So we're going to be taking a more detailed look at the first of the three main usage categories for FME Server that we briefly discussed at the beginning of Chapter 1. So this is self-serve. This chapter is going to cover the services available inside FME Server, as well as ways to give your users control over how a workspace will operate when run. So with that, we're going to start on page 3-3 if you're following along in the training manual. So what do we mean when we use the term self-serve? Basically, it's a term for a system that lets the end user run their own data translation and transformation tasks. This type of system can be configured so that a user does not need to have any prior experience with FME in order to carry out their data-related tasks. There are two types of self-serve systems. The first is data upload, where a user is able to upload their own data sets to be processed on FME Server. So this might be something like a data validation workflow, where a user can upload their data set, run it through a workspace that's going to run some tests and do some validation on that, and maybe send back results to tell them whether or not their file meets the internal data standards. And the second type of self-serve system is data download, where a user would be able to get access to the output of a translation. So a data download user can use the system to fetch their own data from the server. So if they want to be getting, the latest copy of the data sets that are stored in maybe a central database somewhere in your system, they can go into FME Server, choose what data they're interested in, and have that sent back to them inside a zip file so they can download the results of that query. So we'll just start off with a few definitions here. So what is a service? We're going to take a look at the FME Server services. So we'll just start by defining a service in this context. So basically, a service is a tool that handles communication between a client and a server. It provides a simplified interface for complicated functionality. In FME Server, the client, on this side here, would typically be a web browser. It passes different kinds of requests to FME Server using different kinds of FME services. So instead of simply running a workspace, a web page could be made to use a service to ask for the results of a translation to be returned back inside a zip file. So on page 3-5 here, we have a list of all the services that are available with FME Server. So I'll just do a quick rundown of what some of these are. The services that are available can be divided into 4 different categories. So the first category we have are the OGC services. So OGC here stands for Open Geospatial Consortium. So these services, we have the Web Feature Service, the WFS, and the Web Mapping Service, WMS, which will let you register a workspace with these services and provide the output of that using the WFS or the WMS protocols. The next type of services that we have are the transformation services. So these are ones that relate directly to running a workspace to create output. So the services that would be considered transformation services are, first of all, the data download service. So this lets you, when a workspace is run through this service, the output of that workspace will be provided back to the end user or to the client inside a zip file that they can click on a link and download that file directly. Next, we have the data streaming service, which instead of providing the output of a workspace back inside a zip file, it actually provides the output file directly back to the calling client. So if you were to run a workspace through this service that maybe created something like a PDF, you could click on a link to that workspace, have it run, and the PDF will be returned directly back to your browser so you can open it directly in the browser itself. The next one is the job submitter service. This is the service that we used before when we ran our workspace. It simply runs the workspace as is and writes the output to wherever you specified inside the workspace definition. Next, we have the KML network link service. This provides the output of a workspace back as a KML network link, so you can open up that KMZ file inside something like Google Earth and get the results directly inside Google Earth itself. And then finally, we have the schedule service, which lets you schedule workspaces to run at a specific time. The next type of services we have are utility services. These are essentially helper services to interact with the server itself. So we have the catalog service that'll keep track of all the resources that are up there, so you can see a list of, say, all the workspaces or all the custom formats that you've published up to the server. We have the data upload service, which takes care of uploading data sets temporarily to the server. The token service, which can be used for authentication with the REST service down below, which you can use to incorporate components of FME server inside, say, a web application. So you can use these REST calls or the REST API to interact with the server. And then finally, the last category we have are these notification services. So there's only one in here, the notification service itself, which deals with real-time messaging. So we'll take a look at notifications later on. And we're going to focus on the transformation services in the next little bit of this chapter. So as we have seen, when publishing a workspace to FME server, we're given the option to register the workspace with any one of the services. Registering a workspace with a service makes that workspace available for use within that service. However, not every workspace will be compatible with every service. We will see examples of this when we take a more detailed look at each of them. But a good example would be the KML network link service. This would only work with a workspace that writes KML files. You can choose not to register a workspace with any service. When you do this, you will only be able to run that workspace as a regular translation using either the FME server console, which is a command line interface for FME server, or the FME server job submitter transformer inside Workbench. You can also choose to register a single workspace with multiple services. So if you want to be providing a workspace as both a data download and a data streaming option, you can choose to do that if you wish. So take a look at parameters. So every part of a translation has a set of parameters that control exactly what it does. There are parameters that apply to the workspace as a whole. There are also parameters for controlling individual readers and writers. We have parameters for feature types, and finally, parameters for transformers as well. Generally, these parameters are set by the author when building a workspace using FME Workbench. Published parameters, which are also called user parameters, are parameters that the author has exposed to the end users so that they can set the values themselves and therefore have control over the data created by a translation. You can publish any parameter that exists inside a workspace. So if you want to give your users control over maybe a particular setting inside one particular transformer, you can choose to do that. We'll take a closer look at that in just a second. Some of the most commonly published parameters inside self-serve systems include things like the output coordinate system, the feature types to read, so these would allow the user to select which layers they're interested in, say, downloading. And finally, the bounding box, or an area of interest, so that a user can select a specific subset of the features to be able to download that. So FME server provides a number of different ways. So just going to take a look at data uploads here. So FME server provides a number of different ways to make data available to be processed by workspaces on the server. So data can be uploaded from any FME server client, including the web user interface, FME Workbench, or a custom web application. In the context of self-serve, Data upload is typically used to allow a user to upload their own data sets for processing. Data upload is also meant for use by workspace authors to let them upload any additional resources that are needed for a translation to run. So this could include things like custom transformers, maybe template files if you're working with something that requires a template to run. Within FME Server, there are two forms of data upload. We have, first of all, the data upload service, which allows for data to be uploaded temporarily to be used by one particular workspace. So we saw that earlier when I showed you uploading inside the repository here. I'll just quickly open that up. It's a quick reminder. So this option here, the Upload tab for a source dataset, uses the data upload service. This is a way to temporarily upload files to be used by a particular workspace. And the second form of data upload that exists is through the resource folders, which allow the data to be uploaded to a folder on the server, which can then be used by any one of the workspaces. Data uploaded to the resource folders will stay there as long as needed. So we tried that when we uploaded our orthophotos to the orthophotos directory that we created on our server. So the data upload service is a service specifically designed for uploading files to FME Server. These files can be uploaded using the FME Server publishing wizard. So we saw we can upload them through the web interface. We can also choose to upload files when we publish workspaces to the server. So I'll just show you where this option is. I'll just go through the Publish to Server wizard here. So here, if you click on the Select Files button at the bottom of the second page of the wizard, you can choose which files you'd like to upload. So these tells the server which files are to be included when you publish this workspace file up to the server. So inside here, you have two different options for setting where these files should go. So if you click on Change Location, you can choose to upload to a repository. So when you do this, when files are published, they go directly to the repository itself. So any files that are uploaded in this way will be available to the workspace that you're publishing and only to that workspace. So they won't be available to any of the other workspaces on the server. This is similar to using the resources in that data uploaded this way will be permanent, so they'll be copied into that repository folder on the server. They'll always be available to the workspace itself for as long as the workspace exists, but they won't be available to any other workspaces. So that's the difference there. Your second option is to upload to a shared resource folder, and this makes the data available for any of the other workspaces on the server. Okay, so the next section here just gets into the resources folders again. So we've already taken a look at that, so I'll skip over this. This just shows where the folders can be found. So when you create new folders inside the resources section, it does create an actual folder that exists in the Windows file system of the machine where server's been installed. So if you wanted to take a look at that, you can find it in the server install directory. And you can find the files that you'd published or that you'd uploaded to resources. So I can show you that on these machines quickly. So since server's installed on the same machine here, we can find it. If we go to the C drive and then Apps, FME Server, and you'll see here the data folder that existed in the resources. And if you go inside there, you can see the orthophoto and the output folders that we've created through the web interface. So those actually correspond to physical directories on the machine itself. So if I wanted to add more TIFF files to this directory, I could choose to drag and drop them in, and then once they're in there, I could actually see them in the web interface there as well. So there's a few different options for being able to deal with uploading resources in this way. Okay, so with that, let's work on exercise 3A. So we're going to start building up a self-serve service for our end users in the next few exercises. So each exercise that we do in this chapter is going to build on the last one. So here we're going to use the data upload service to create a solution for data providers to upload their data to FME server and run some simple quality assurance tests on them. So we're going to create a brand new workspace for this exercise. So if you've got a workspace open in Workbench, just close that down for now. And we're going to start with a brand new workspace. We're going to start with a blank workspace this time. So from the Getting Started section of the Start tab, just click on Blank Workspace. And we're going to add in a reader. So we want to be able to read in the data that our data providers are publishing or uploading to FME server. They're going to be publishing GeoTIFF files. So we'll add in a GeoTIFF reader to our workspace. So under Readers, we'll go to Add Reader here. Under Format, we'll choose GeoTIFF. And then we can select any one of those TIFF files from our orthophotos directory. So open up the file browser and just select any one of these. And here, again, just like last time, under Workflow Options, we're going to choose Single Merged Feature Type so that we can read in any one of those TIFF files from our orthophotos directory. So here, make sure you've selected Single Merged Feature Type and then click OK to create the reader. So now we'll have a single GeoTIFF reader that is set to be able to read in any and all GeoTIFF files that we select. So next we'd like to add some validation into this workflow. So the first thing we'll do is we'll add in a transformer called the raster properties extractor. And this is going to read the raster file that has been uploaded and just grab some information about it to make sure that the properties match our internal data standards. So to add in that transformer, just click anywhere on the canvas inside Workbench and start typing the name. So start typing in raster properties and keep going until you see it in the list down below and click on it from in there to drop it into the workflow. We'll just connect it to our reader. And then we can take a look at the properties inside the transformer. So click on the Properties button or double click anywhere in the top part of it. We'll just see there aren't any properties to set for this, so all it's going to do is it's going to grab the information about this raster and put it out into attributes. So once we've verified there's nothing for us to set inside there, we're going to add in another transformer. So we want to test to make sure these properties match what we might expect. So we're going to use a tester transformer for that. So to place that in, click to select the raster properties extractor and then start typing the name of the tester. And click Enter to drop that into place. So here you'll see the Properties button is red. This indicates that we need to set some properties inside here. So double click on the tester to open it up and we'll set up our test. So you want to set it up the same way as shown in step 5 here in the exercise. So for the left value here, just double click inside the little cell, click the drop down arrow next to it, highlight attribute value. So we want to be testing the value of an attribute inside here. And the attribute we want to be testing is the number of bands that exist in this raster. So from the list of attributes, select num_bands. So your left value will look something like this. That little brown arrow indicates that this value is coming from an attribute value. We want to test where the number of bands equals 3. So we only want 3-band rasters. So under operator, double-click that to select the equals. So number of bands equals. And then under right value, double-click inside there and type in the number 3. You'll see when that's done, it'll have a little K next to it, indicating this is hard-coded to a constant value. And then we want to repeat this process and add in a couple more tests. We want to check that the X and Y spacing of our raster is equal to 1. So we'll add 2 more tests for this. So under the second test clause, just double-click, choose the drop-down. Under attribute value, we'll select spacing underscore X equals, and double-click on the right value to type in 1. And then we'll repeat this for the spacing Y. So double-click under the drop-down attribute value, and then spacing underscore Y equals 1. So the next thing that we'll need to change here under pass criteria is to adjust what our pass criteria is. By default, it's set to an OR, so this will pass the test if any one of these is true. What we want to do is make sure features only pass if all of these are true. So we'll set this to pass criteria equals all tests, so it uses an AND comparison. So if number of bands is 3 and spacing is 1 and the spacing of Y is also 1, then these features will pass this test. So once you've finished setting up your tester, click OK to accept those changes. And we'll continue with building up this workflow. So next we want to provide some feedback to the people who've uploaded their data sets as to whether or not their data passes or fails our validation test. So we're going to do that by creating some very simple HTML that's just going to have a little message in there to say whether it passed or it failed Q&A. So we'll start off with building up some HTML for the failure option. So if our data fails our test, we're going to use an attribute creator to build up the HTML that's going to send the feedback. So click to highlight the failed output port on the tester. So you should see it turn orange when you do that. And we're going to drop in an attribute creator transformer. So start typing attribute creator and click enter to drop that into place. And we'll see that it should be connected to the failed port now. And let's open up the parameters on this to create our HTML. So our attribute name in this case is going to be text line data. So make sure you type that in exactly as it is. This will be important for when we put in our writer. So the attribute name here will be text, text with an X, underscore line, underscore data. So this will be all lowercase with underscores in between each. And then for value, click in that cell and click the 3-dot button here to open up the text editor. And then this is where we're going to put in the HTML with our QA results. So just type in the HTML exactly as shown in step 6 here. So it'll be HTML tag with a paragraph tag next, data QA test failure. And we'll close the paragraph tag and then close the HTML tag. So at this stage, this is what you should have inside your text editor. All right, and when you're done that, click OK to accept that. And then OK again to close the Attribute Creator Parameter dialog. And then next we want to do a similar thing for our past features. So we're just going to duplicate the Attribute Creator this time and save us a little bit of time. So right-click on the Attribute Creator that we currently have and choose the option to duplicate. And that'll drop a second Attribute Creator into the workflow. Connect that one to the past output port on the tester. And then we'll open it up and change the message from a failure to a success message. So click on the parameters and double click on, or click on value and choose the browse or three-dot button here. And we'll just say data QA test succeeded. So when you've made that change, click OK, and then OK again. So we should have two attribute creators now, one for successes and one for failures. And our final step here will be to add in a writer that will write out that HTML for us. So to add in the writer, we're going to go up to Writers from the top menu, and then choose Add Writer. So the writer format we're going to be adding in is a text file, so it's just going to be creating text for this HTML. So under Format, type in Text, and choose the text file writer. Dataset, we'll just put this into our output directory, so click on the File Browser button. And we'll go under Favorites to FME Data 2014, to the Output folder, and we can put this inside our training folder. And we'll call this output.html. So make sure at the bottom under Save as Type, you select all files. So output.html, and then Save as Type all files. So when you've set that up, click Save. And then before we add in our writer, we're just going to change one of the parameters inside. So click on the Parameters button down below the dataset. And we want to change the MIME type. So this is a keyword that'll tell the client that calls this workspace through FME server what type of data is going to be coming out. So we want to be able to tell our client that we're going to be writing out HTML instead of just plain text. So under MIME type, select text/HTML. And then click OK to accept that parameter change. And then OK again to add in our writer. And now connect the text line writer to both the attribute creators that are connected to the tester. So you have both of them writing out to the same writer here. And you'll see the text line writer has an attribute called text line data. This will correspond to the attribute that we've created. So this tells the writer to take the text that was added to this attribute and write that out to our output file. And the final step for configuring our workspace will be to delete any published parameters that might have been created by default that we're not going to need in our self-serve service here. So in the Navigator window on the left-hand side of Workbench, go to the section called User Parameters and expand the published parameters. You'll see there are 3 there by default. We've got the source dataset, the feature types to read, and the destination dataset. So we want the source dataset in there because we want our users to be able to choose which files they want to run this workspace with. But we don't care about the location or the feature types to read. They are meaningless in this particular context. So let's remove those as published parameters. So to do that, select first the feature types to read parameter, right-click on it and choose Delete. And then we'll do the same for the destination dataset. Right-click and delete. So we should have only one published parameter inside this workspace now. So now that we've finished building up this workflow, let's save our workspace. And we can put this, say, in the output folder again. So under FME data, output. And I'm going to call this exercise. This is 3a.fmw and choose save. And then it's always a good idea to try testing your workspace in Workbench just to make sure there's no errors inside. So let's choose prompt and run translation to test this out. And we can choose any one of our TIFF files to validate, and then click OK to run it. We should see translation was successful. If we take a look at the feature counts inside the workspace, we can see that our raster went into the tester and passed our validation. And we can check our output. If you right-click on the writer feature type and choose Open Containing Folder, we can see the HTML file that was created. If you open that up, we can take a look, maybe using Chrome. And we can see Data QA test succeeded. So that's working as expected, so that's good. So the next step will be to take this workspace and publish it up to FME server to create our validation workflow. So under File, choose Publish to FME server. We'll use the same connection information as before, direct connection localhost, admin as the credentials, and go on to the next page. We'll want to publish this as exercise 3A into our training repository. Down below, we'll see that we have one file that's being uploaded by default. If you choose Select Files, we can take a look at it. It's that source dataset, that TIFF file that we generated our workspace with. In this case, since we want our users to be uploading their own datasets, we don't need to upload the source dataset for this. So uncheck the box to upload data files. So we're simply uploading the workspace with no data for the source at the moment. We want our users to provide our source data. So when that's done, click Next. And then we'll register with our services now. So we'll see we've got the job submitter service by default, so that's fine. But in this case, since we're creating an HTML page, it would be nice if when we run this workspace through server, the HTML that we create simply comes back to the browser directly. So we can do this if we register our workspace with the data streaming service. So if you check the box next to data streaming, we can register with this service. You can double check the properties, so click on the edit button next to it. And just make sure the output datasets to include includes the output text line writer. So what this does is it tells the server that we want to stream the output created by our text line writer directly back to the calling application. So if we run this through a web browser, we tell the server to take the output from this writer and simply push it directly back to the browser itself. When we register with this service, the output dataset location is actually going to be overridden by FME server, and it's going to publish that just straight back to the calling client instead of writing out to whatever location we had set inside our workspace. So when you've finished registering with the data streaming service, we can click Publish. And we should see our workspace was published to the server, no resources uploaded, and we registered with both the data streaming and job submitter services. So this is optional in this case. It's nice to have it registered with the job submitter service so you can test out the workspace if you want. But in this case, the data streaming service was the important one for our particular workflow. So with that, let's try running this workspace now. So open up your web browser, and we'll go into the server web interface. Click on repositories, and we'll go into our training repository. And we should see now we have a second workspace in here, exercise 3A. So click on that workspace, and we want to run it through the data streaming service. So make sure when you click configure, it's the one under data streaming. So click data streaming, configure. So now you'll see in the list of published parameters, there is only the one parameter that corresponds to the single parameter that exists inside our workspace. For this particular workflow, let's use the upload option to upload a data set temporarily. So click the Upload tab from here. To upload our file, we will use the File Upload section in the interface at the top here. So under File Upload, choose Add Files. And we're going to start by testing with some good data. So we have a data set for this. If we go into Favorites, FME Data 2014, and this can be found in the Resources folder. And then there should be a data set in here called, well, let me see where the path was. Okay, so we have a self-serve folder in here. So this contains the data for our self-serve service. So we'll test it with some good data first. So select gooddata.tiff, choose open. This uploads it through the web interface. You'll see that it's completed now. In the Upload tab, we'll now see our gooddata.tiff as an option. So let's check that. So this runs the workspace with this good data as the source. And let's choose Run Workspace. And we'll see now, this time, instead of the server coming back with the page with the job results, it's actually just pushed the results of the workspace directly back to the browser. So this is our HTML page with our data QA succeeded message. So this is the power of the data streaming service. So what I could have created a much more complex, say, HTML page here. I could have streamed back, say, a PDF or basically any file format that would be compatible with this particular type of browser. So anything that I can open directly in the browser can easily be streamed back directly from the workspace here. Okay, so let's test this one more time and try with some bad data just to make sure everything is working. So we can go back up. So we'll head back to our configure page here. Let's add a new file through the file upload. And we're going to upload the bad data.tiff. Click open. You see that's also been uploaded. So we'll uncheck the good data from down below and check the bad data as our source. And we'll run the workspace again. And we'll see this time the QA test failed. So here we have our message coming back depending on the results of that test or inside our workspace. Okay, so that's how the run through of creating a very basic self-serve service using FME Server to power the workflows in the background. So I think at this stage it's time for another break. So we're going to stop now for another 10 minutes and we'll come back at 10:44 Pacific time and we'll pick up where we left off. So we're going to take a look at the data download service next. So we're stopping for a 10-minute break right now. Okay, so we're back again. So we're just going to continue on where we left off in this training. So we just finished creating a self-serve service based on the data upload service inside FME. So we were allowing our end users to upload their own data set and run a data validation workflow on that and get back results directly into their browsers when they run this through the web user interface. So the next thing that we're going to look at is working with the data download service. So the last service we used was the data streaming service, which overrides the output location and simply streams the output file back to the calling application. So the data download service here is a slightly different variation on this. So it also deals with the output from a workspace. And so we'll just take a look at the data download service itself. So the data download service is an important one for setting up a self-serve workflow with FME server. We saw in the previous exercises that the job submitter service runs a workspace and writes data out to the location specified in the workspace. The data download service also runs a workspace, but instead of writing the output to the location set inside the workspace, it will override that setting and write out to a zip file and then present the user with a link to download that file. To create a data download service, you simply need to register your workspace with the data download service when publishing it to FME server. Once it is registered, you will see the data download option become available in the server web interface. So it'll look something like this down here below. So we're going to do this, work on dealing with the data download service in the next exercise. So we're moving on to exercise 3B now, and that is on page 3-22 if you're following along. So we're going to actually work on creating a data download service using the workspace that we began creating in chapter 2. So from here on, each of the exercises that we're going to be doing will be building on the last one. So let's begin with a starting workspace. So it'll be the same workspace as the one that we created before, but we'll just use a clean one to start here. So open up FME Workbench, and under File at the top, select Open, and then we'll browse to the location where the starting workspace exists, so you can use the path as shown here at the top of page 3-22. So from the left-hand side, let's go to FME Data 2014. We'll look inside the Workspaces folder. And in the Server Training folder, so it's Server Training here, not Server Manual. And we'll look for Exercise 3B Begin. So this is the data download workspace. So it's Exercise 3B Begin Data Download. And so we'll open that up. It's a very straightforward looking workspace. Zoom out a bit here. Simply has a reader directly to a writer. So it's GeoTIFF to JPEG. So it's exactly what we'd created before. So let's start out by cleaning up this workspace a bit. So we're going to go and clean up some of the existing published parameters that we no longer need. So under User Parameters, go to Published Parameters, expand that, and we'll see here we have two published parameters, one for the source GeoTIFF file and one for feature types to read. So we don't need our users to set any of these parameters. So actually we want them to be able to set the source, so we'll just delete the feature types to read. So right click on that and choose delete. So we only have one published parameter left inside the workspace. So that'll be the parameter for the source dataset. And then next we want to add some additional transformers into this workspace. So we want to take the source data that the user selects, and we want to resample and mosaic it so that we take all the data sets, we maybe resample it to a smaller, a lower resolution, and then we want to mosaic them, stitch them all together into a single raster file. So we'll do this using a few different transformers that we're going to add into our workflow. So we'll start by placing the raster resampler transformer. So click on the connection between the reader and the writer and start typing the name of the transformer. So raster resampler. When you see it highlighted in the list, click enter to drop it into place. So let's set up this transformer now. So click on the cogwheel or the parameters button. And we want to change this so the size specification is done by cell size. So click the drop down there and choose cell size. And then for the X and Y spacing, let's set this to 5. So put in the number 5 for each of those. And then we'll make sure our interpolation type is set to nearest neighbor. So when you have that set up, click OK. And then next we'll add in a raster mosaicer to take any of the source data sets and mosaic them together into a single raster file. So click on the connection between the resampler and the writer, and we'll drop in a raster mosaicer. When you see that, click enter to drop it into place. We can open up the parameters if we want to double check them. They're okay at their default values for now, so click OK to accept that. So next, what we want to do is modify our writer feature type, our destination feature type. So to open this up, to open up the parameters for this, click on the cogwheel or just double click on the feature type itself. And this opens up the feature type properties dialog. So for the feature type name, we want to make sure this is hard-coded to AirPhoto Mosaic. So if you opened up the workspace from the server training folder, it will already be set like that. If you're using the workspace that you'd created earlier, then you'll need to uncheck the fan out by attribute and put in a feature type name of AirPhoto Mosaic. So when you finished this, let's save a copy of this workspace. So go to File, Save As, and we'll just save this into our data output folder. And I'm just going to call this exercise 3B. And we'll save it. And now let's publish up to FME server. So you can do that from the File menu. So click on File, Publish to FME server. And then use the same connection credentials, admin for the username and password. Click Next. We want to put this inside the training repository. We don't need to upload our data file, so we can uncheck that. And then click Next to register with the data download service for our data download workflow. So check the data download service. You can uncheck the job submitter service if you want. It's nice to have it there sometimes for testing. So under data download, let's double check the properties. So click the edit button. And we'll make sure the output dataset to include is set to our JPEG writer. So the JPEG file that's created is going to be included inside the zip file that the data download service produces. So when you're sure that's set up okay, click OK, and then click the Publish button to publish this workspace to FME server. So now let's go to the server web interface and try running through the data download service, and we'll see how that compares to running through the data streaming service. So I'm just going to go back to localhost /FME server. And from inside here, go to the repositories. I'll open up the training repository. And then we'll go into exercise 3B. We'll see under registered services, we have the data download service here. So let's click the configure button and see what we can set up in here. So we'll see here we have a single published parameter for the source GeoTIFF files. And we can use the browse option to select any or several of the TIFF files for our source. So we can find that under data and then orthophotos. Just expand that a bit, there we go. And maybe select a couple of these files, or maybe all of them if you want. So what's going to happen with this workspace now is we're going to take in all 4 of these TIFF files. We're going to resample and then mosaic them together into a single raster. So if I run the workspace now, it's going to run through the data download service. And we'll see the difference in just a second when this finishes. And you'll see it comes back with the success page. So this is very similar to what we saw when we ran through the job submitter service in earlier exercises, except now you'll see this section here with the data download URL. So this actually contains a URL that I can use to download the output of my workspace. So if I click on this now, I'm going to download a zip file directly to my browser here. I can click on that. You'll see inside my zip file, I have the server training folder. And inside here, I have my AirPhoto Mosaic JPEG. And if I open that up, I can see a JPEG image that's been created with the 4 TIFF files stitched together into a single mosaicked raster file here. So that's the basics of the data download service for this. So we'll see we ran this and we get a zip file containing our output instead of getting our output directly or having the output written to wherever was specified using a published parameter. Okay, so just to do a quick check on how everyone's doing, can you please raise your hand if you're able to get the data download service working properly and you're able to see that single JPEG file created? Okay, perfect. Looks like most people have that going, so great, thank you. And again, if you have any questions or you ran into any trouble, please feel free to send us a message through the questions panel. Erin's here, he can help you out and get you back on track with that. So that's the end of example 3B. So with that, we're going to move on to page 3-27 in the training manual. And we're going to take a look at some miscellaneous published parameters. So what we did in our last exercise is we created a fairly basic data download service. We created a workspace that had a single published parameter for the source data set and published that up to FME server and registered with the data download service. So when our users logged into the FME server web interface, they could go into this workspace, they could go into the configure page and select the files that they're interested in downloading, and then click the run button to run the workspace. And then they were provided back with this data download URL that links to a zip file that contains the data that was created by the workspace. So now what we're going to do is we're going to look at some ways to provide our users with even more control over exactly what happens inside the workspace. So this is going to go beyond selecting the layers they're interested or selecting the data sets they're interested in. We're actually going to look at being able to configure exactly how the data itself is being created for the output that they're going to be able to download. So with that, let's start on page 3-27. So any type of parameter that exists inside a workspace can be made into a published parameter. They do not have to be specifically related to the data download service. You can find all the parameters that are related to a particular workspace inside the Navigator window inside Workbench. In there, you can find a list of parameters that are related to the readers and the writers, for individual feature types, and for all the transformers that exist inside the workspace. So I'll just show you that quickly using the workspace that we created in the last exercise. So inside here, if I open up the Navigator window, I can see, first of all, I can see the list of readers and writers inside the workspace. And then if I go into the readers, I can expand that. And down below, I have a list of all the parameters that apply to the reader itself. So these parameters control exactly how the data is going to be read into the workspace when it reads the source data sets. So here's where you'd find all those parameters. Further down, you can see the list of feature types that are associated with this particular reader. And for each feature type, you can see a list of all the parameters that exist that correspond specifically to that particular feature type. So these are parameters that would relate to exactly how specific layers or tables are read into the workspace. So you can see in this example, there actually aren't any parameters related to this GeoTIFF feature type. Every reader or every writer, every format inside FME will have a different set of parameters. So depending on the type of data that you're working with, you may or may not see parameters listed here. We can take a quick look at the writer as well. So this is the JPEG writer. You'll see the list of parameters related to the writer itself is fairly limited this time, but there's still a list of options that you can control. Down below here under my feature types, I can see a list of all the parameters that exist that relate directly to that feature type. So you can see in this particular format, we have some options that do relate to this feature type, this particular output only. And then down below this, I can see a list of all the transformers that exist inside my workspace. So you can see there's two. We've got the raster mosaicer and the raster sampler. If I expand those options, I can see a list of all the parameters that relate directly to this particular transformer. So what we can do with that information is we can actually take these parameters either at the transformer level or at the reader-writer feature type level, and we can publish those to make them available to our end users when they go to run the workspace. So in order to publish a parameter, all you have to do is locate it inside the Navigator window in Workbench. You can then right-click on any one of those parameters, and you can choose the option to create a user parameter. You will then be given the option to configure the parameter by choosing first its type. So there's a drop-down list of all the different types supported inside FME. And then you can configure the text, maybe the prompt that is going to appear when the user is prompted for a value for this particular parameter. So it's usually some descriptive text to let them know exactly what this is about and what changing this value will do to the output that they're going to receive. And then optionally, you can choose a default value for any one of the parameters. Once a parameter has been published, it will then be made available to the user at runtime. So in order to try this inside Workbench itself, you would need to use the prompt and run option to run the workspace. You can see that from the drop down here. So when you run the workspace, a dialog pops up that prompts the user to fill in values for each of the parameters that they have the ability to control. Inside FME server, these published parameters would be shown inside the configuration page. So we saw a little bit of that already in our last exercise. After we'd published our workspace to the server and we went to the configure page to run the workspace, we saw a list of options where we could select the source files that we wanted to download through the data download service. So that's an example of what one published parameter would look like inside the configure page on FME server. So with that, let's just take a closer look at two specific types of published parameters that exist inside FME. These are two parameter types that are particularly useful within a self-serve environment. And these two parameter types are choice with alias and scripted parameters. So the choice with alias is a parameter type in which the user is given a set of choices that are presented with a user-friendly display name in the front, but then actually return different value to FME behind the scenes. So there's one example of that here on this page. and it's dealing with a published parameter for the users to select the size of labels that are going to be written out onto the output data set that they're going to receive through this data download service. So in this particular case, we have, these are the values in the value column that are actually submitted to FME. So what we could do is we could just create a simple choice parameter with these values and let our users select from 1 to 4. But using the choice with alias or choice with display name, as it's shown here in this dialog, we can actually present the users with a slightly more intuitive list of options. So you can see that under the display name column here. So we could have the value, which is just a 1, which is an arbitrary number, so these users may not know if it's 1 centimeter, if it's 1 kilometer, that they have no way of knowing. So we can present them with a display name to give them some additional information about exactly what this value is actually going to mean when they do select it for their label sizes. This parameter also comes in handy in a few other situations when building up a data download service. And we're going to take a closer look at this in the next few exercises. So we're going to be creating a few of our own choice with alias parameters to make selecting some options inside our data download service much simpler for our end users. The second type of parameter that I'm going to point out here is what we call scripted parameters. So these are a special type of parameter that actually provide a way to allow you to use either a Python or a TCL script in order to generate a parameter value. So they can incorporate information from other published parameters. So they could take in information provided by a user through one parameter, process that information using a script, and then produce another value that would actually be used inside the workspace. So these types of parameters can provide quite a bit of flexibility inside your workspaces, and it gives you lots of different options to be able to do fairly complex calculations and complex processing of these parameter values before they're used inside the workspace. So it does provide quite a lot of power inside FME. So with that, we're going to try adding some published parameters to our data download workspace in the next example, and we're going to move on to example 3C in the training now. Okay, so here we're just going to be taking our workspace and we're going to be adding some additional published parameters to let our user have a little bit more control over the type of output that's being created within our data download service. So the first parameter that we're going to create is we want our user to be able to decide what resolution the images that are going to be created will be in. So the resolution is controlled by the raster resampler here, so it'll control the cell size. And we're going to create a published parameter for that. So to create that parameter, we're just going to create one directly inside the navigator. So right-click, so find the user parameters in the list in the navigator on the left-hand side of Workbench. Right-click and choose the option to add a parameter. This will let you create a brand new user parameter from scratch, so you can set up exactly the way you would want. So under Type, let's click on the drop-down. We want our user to select resolution, so this would be an integer value. So select integer from the Type option in the drop-down there. Under Name, let's call this resolution. We want to make sure this is available as a published parameter so our users can set it themselves. And we'll uncheck the optional value here. We want this parameter to be a mandatory option that they set. Inside prompt, this is the text that the user is going to be presented with when they see the list of published parameters. So you want to give them a useful prompt here to tell them exactly what kind of value to put in and what this is going to do and how it's going to affect the output that gets created. So the prompt here, we'll call it image resolution. And they can enter in a value between 1 and 50. And then down below, we'll set a default value. So this will default to 5 if the user chooses not to select a value. So when you've finished entering in the information for this parameter, click OK. And we'll now see that there are now 2 published parameters listed in this workspace. So the next step that we want to do here is we want to actually link this published parameter to the values inside the raster resampler. Currently, we have this parameter published, so the user can put in any value they want, but it's not linked to anything, so it won't actually do anything until we tell the raster resampler to get its value from this published parameter here. So to do that, double-click on the raster resampler, and we're going to modify the X and Y cell spacing values to get their values from this published parameter. And we'll do that by clicking on the drop-down arrow next to the cell spacing values. And down here, we can set it to a user parameter. So highlight user parameter, and we're going to tell it to get its value from the resolution parameter. And then we'll do the same for the Y spacing, so they'll always be the same. So click the drop-down, user parameter, and resolution. You'll see here now we have this little purple cogwheel. This indicates that this value is coming from a published parameter value. So when you finish that, click OK to accept that change. And then we're going to add one more published parameter to our workspace to allow our users to control the level of compression that the JPEG writer uses. So if we take a look in here, if we open up the JPEG writer feature type, under Format Parameters, we'll see in the Format Parameters tab, there's this compression level option in here. So what we could do is we could go in here, right-click User Parameters, and create a brand new parameter from scratch. But we can also, in this case, just generate a published parameter directly from the parameter in the Properties dialog here. So under Format Parameters, go find the compression level and click the drop-down arrow next to it and highlight User Parameter. So from here, we can set this to an existing parameter, or we can use the top option to create a new user parameter. So click Create User Parameter from here, and we'll see the Add Edit User Parameter dialog now defaults to options that make sense given the parameter that we're publishing. So the name defaults to the compression level. The prompt defaults to the same prompt as in our dialog. And then a default value of 28 is specified there. So those options make sense, so we'll leave the default there and then click OK to actually create this user parameter. And we'll see this now changes to a published parameter here. And when we click OK here, we'll see the list of published parameters now includes a third option for the compression level. So now let's test out our workspace and see if it's working properly. So to make sure that we can test our published parameters, you'll have to use the prompt and run option. So click the green arrow with the red question mark. And we'll see we've got an option for our source files, our image resolution, and our compression level. So under source files, maybe we can select a few from the list here and click open. And then image resolution, let's test out these values by setting them to the highest levels. So set image resolution to 50 and compression level to 100. So this will make a very low resolution, poor quality image. So we can tell for sure that the writer is working as expected and our published parameters are having an effect. So click OK to run that. So that'll just take a second to read in those files, compress them, resample them, and write them out to a single JPEG. And we can right-click on our output feature type, choose Open Containing Folder, and let's open up the JPEG that we just created. And it should look pretty awful, something like this. So that indicates it's working. So we can always adjust the values in our published parameters to make this look nicer if we wanted a better image resolution, but this does indicate that those parameters are controlling the output that we create. So now let's publish this workspace up to FME server to create an even better data download service. So go to the File menu, choose Publish to FME server, use the same connection information. We don't need to upload any data files, so we're going to use the ones in our resources. We can call this workspace exercise 3C if we want to have a different one, or we can choose to overwrite the exercise 3B that's in there already. I'm just going to go with exercise 3C to keep these all separate. Choose Next. We want to make sure we register with the data download service, and let's publish to FME server. So we should see successfully published down at the bottom. And now let's run this through the web interface. So I'm going to go into repositories and open up the training repository and open up exercise 3C that I just published. And under data download, click configure. And I'll see under published parameters, I have the source GeoTIFF file that was there before. But I now have two more published parameters, the image resolution and the compression level. So for my source files, I'll just use the browse option. Oops. Browse into the data, orthophotos, and maybe select two of these. And then image resolution, maybe I'll change these values up a bit, make it a resolution of say 15, and I'll only compress it to 25. So you can choose any values you want, and then we can run our workspace to get the output that we have decided we'd like to see. I can choose to download the zip file with the output, and if I open it up in here, I can take a look at the JPEG that's created. So you can see it's a bit of a higher resolution image than before, and I was able to control exactly what kind of resolution and what kind of compression level was used when this JPEG was created. So that's a good example just showing the kind of power that you can present your users with by using published parameters to allow users to control exactly what happens inside a workspace. So you can have parameters for basically any aspect of any kind of workflow that you're creating yourself. So it allows your users to customize exactly what they want to see when they download the results at the other end. Okay, so we're going to continue on through the authoring manual here. So we're on page 3-34 now. So a good example of a common parameter that is used in self-serve scenarios is for the output coordinate system. This lets the user choose the coordinate system of the data provided by the data download service. Dataset reprojection can be set up using the coordinate system parameters under the readers and writers in the navigator window. So you can see that pointed out here in the screenshot on the page, coordinate system for the readers and coordinate systems for the writers. Or you can use a reprojection transformer to control this. So for example, we have the CS map reprojector. The advantage of using a transformer in this case is, as shown in the screenshot, that you'll have more control over additional reprojection parameters, including the geographic transformation and, say, grid height. So if you use the coordinate system settings on the readers and writers, it simply uses a default settings for the type of transformation and all that. So if you've tested it out yourself and you like the default behavior and that's good enough for what you're doing, that'll work well. It's quick and simple. But if you need more control, something like the CS map reprojector or any of the other reprojector transformers would probably be a better match for you. So flexibility is important when it comes to creating workspaces for self-serve systems. Creating a flexible workspace allows for a single workspace to meet the needs of as many users as possible. So one way to accomplish this is by not tying your workspaces down to a single format. the generic writer can help you do that. So as we can see in the workspace that we've created already, our users do have some control over, say, resolution and compression level, but they'll always get a JPEG file at the other end no matter what they do. So we can change that if we wanted to allow our users to, say, download in the format of their choosing. We could do that by using the generic writer instead of a format-specific writer. So the generic writer itself contains a parameter to control the output format that will be written by the workspace. You can see that down here in the parameters options. By publishing this parameter, you can let the user control the output format at runtime. There are a couple of things to keep in mind when you're using this particular writer. The first one is that the output format will automatically be published when you add in the writer, but that parameter will only appear as a text field when run from FME server's web interface. So what'll happen if you publish a workspace with that default parameter is that your users are going to have to type in the short name of the format of their choosing. So if you have users who are very familiar with FME and happen to have all the short names memorized, that might work. So if they wanted KML, for example, they'd have to type in OGC KML. But what you can do instead is actually modify that parameter using something like a choice with alias parameter to allow users to select the format that they're interested in from a list instead of having to type in the format name. And then secondly, a good point with this is that all writers have their own set of parameters that are specific to that particular format. So we see that with JPEG, for example. JPEG itself has, say, this attribute for controlling the compression level, for example. That doesn't exist in every single format, so this is a JPEG-specific type of parameter. So when you use the generic writer, these types of parameters are not going to be available because they don't exist on all writers. So if you need to control writer-specific parameters, you can do this by adding a writer of that format into the workspace and setting the parameter on that writer. When the generic writer is used to write out to that format, it will actually check inside the workspace to see if there are any writers with that format that exist in there, and it'll actually take the values from those parameters and use that when it writes out to that format using the generic writer. So essentially it involves adding a dummy writer with the settings that are configured the way that you would want to see. All right. So there is an advanced task that shows going into that, so we'll see if we have time to get into that in the exercise here. So next, let's just move on to example 3D, and that's on page 3-37. So we're going to work on adding some parameters for the output coordinate system, and we're also going to modify our workspace to use the generic writer. So just looking at the time now, I think maybe it's just time to take a quick 10-minute break. So we'll stop for 10 minutes now, just to stretch our legs and all that. And then we'll come back and we'll work through this data download exercise. So we'll stop for 10 minutes now, and we'll come back at 11:40 Pacific time. Okay, so we're back again. So this will be the final hour, the final segment for the server training for today. So we'll just continue on and see how far we get inside Chapter 3. And we'll keep going until about 12:30 Pacific time. So we were just looking at exercise 3D on page 3-37 in the training manual. So we were just about to get started on this exercise. So in here, we're going to be adding in a few additional published parameters to our workspace. So we want our users to be able to set the destination coordinate system. And we want to add in a generic writer this time to allow our users to select the format that they would like to download their data in. So with that, we can start off with the workspace that we've been building. So if you have exercise 3B still open in Workbench, we'll start off with that. If you need to open up a new workspace or new version of this workspace, you can find the starting workspace in the location specified at the beginning of this exercise. Just a note that server manual is called server training on the EC2 instances, and everything else should be about the same. So the first step that we'll complete here for modifying our workspace is to delete the JPEG writer. So this writer is tied down to a specific format. We want to replace that with a generic writer so that users can choose any format that they want for their output. So to delete the JPEG writer, just right-click on the writer feature type and choose the option to delete. It'll ask you if you want to remove the reader and writer that corresponds to the feature type. Click yes, and that'll delete the JPEG writer. So what we want to do next is add in the generic writer this time. So under Writers at the top, click on Writers, Add Writers, or Add Writer. For the writer format, let's select Generic. So we have a writer here called Generic Any Format. For Dataset, click on the Browse button, and we'll just browse under Favorites to FME Data 2014. We'll click on the Output folder, and I'll put this into Training. Then click Select Folder to select that option. And then we'll need to click on the Parameters option for the writer. So click on the Parameters button, and here it needs you to select a format. So what this tells the writer is it just tells the writer to default to a specific format when it's being used, so that the generic writer knows to create something when this workspace is run if the output format is not selected by the user. So for the default format, we can set that to JPEG. So under Output Format, choose JPEG, click OK, excuse me, and then OK again to add in the writer. So you'll see here it asks you if you want to add a new feature type for this writer. So click Yes on this dialog, and it'll ask you to set up the feature type properties. So what we want to do here is change the feature type name to the same name as before. So we'll call this Air Photo Mosaic. And then under Allowed Geometries, since we're working with raster data, we want to set this to FME_raster. So this tells the writer that raster data is going to be passed through, so it knows how to handle it properly. When you're done with that, click OK to accept that change, and that drops the new feature type into place. And we can connect that to the output port of the raster mosaic or transformer. So that part is done. And now let's take a look at adding in a parameter to control the output format that the generic writer is going to use. So to do that, we're going to create a brand new published parameter. So right-click on the user parameters from the Navigator window and choose the option to add in a parameter. So for this, We want our users to be able to select the format that they want from a list of choices. So we're going to use a choice with alias type parameter for this. So under type, find the option called choice with alias. We're going to call this parameter format. It will be published, but not optional. So the user has to select a value for this. Under prompt, we can just say choose format. And then for the configuration, click on the Browse button next to that to configure this parameter. So we want to put in a list of options for our users. So we don't want them to be able to select just any format inside FME because they're dealing only with raster data. So we're going to need to allow them to choose from a list of formats that support raster data itself. So we'll just provide them with a list of 3 different formats. We want them to be able to choose from JPEG, ECW, and GeoTIFF. So to do that, let's configure this parameter. So we can do that either by typing in the values and display names manually, or since we're dealing with a writer format parameter, we have some options inside FME to allow you to import these format options. So under import, click the import button, and we can choose to import writer formats. So this just lets us add in the formats that we want our users to select from the full list of all FME supported formats. So let's add in the 3 that we want our users to be able to select from. So from the search at the bottom, just type in the names of the 3 that you're interested in. So the first one will be JPEG. So search for JPEG. When you see it come up in the list, click the checkbox on the far left-hand side to select that particular format. And then we'll search for our next one. So the next will be ECW. And we'll see that appear in the list and check that one as well. So it's ER Mapper ECW. And then finally, we want to select GeoTIFF and click to check that one as well. So you'll have these 3 raster formats as options for your users to select from when they go to run this data download service. So click OK to accept that change. OK again, so you'll see the display name and value have been pre-populated from that import list. So we have a user-friendly display name and then the actual short name in the background that's going to be submitted to FME itself. So we'll click OK again here, and then OK one more time to create the user parameter. So again, you'll see we've added that parameter to the list, but it's not linked to anything at the moment. So we want to make sure we link the format parameter we just created to the output format parameter on the generic writer. So if I expand the options under the generic writer here, we'll see that the output format's actually already published, but it's linked to a parameter called generic out format. So this is the parameter that was created by default. If I right-click and choose Edit Definition, you can see it's formatted in a slightly different way. So this parameter, if we kept it by default, would tell our users to type in the short name themselves. So we don't want to keep that. So right-click on that parameter from the published parameters list and choose Delete to delete the generic output format parameter that was created by default. And you'll see the output format is no longer linked to a published parameter. So now we want to link this to the format parameter we just created. So we can do that by right-clicking on the output format parameter under the generic writer here. So right-click and choose Link to User Parameter. And from here we can select the parameter that we created, the format parameter, from the list. And when we click OK, we'll see the output format is now linked to the format published parameter that we created. You'll see it's red and not purple by default at the moment because there is no default value selected, and this is a mandatory parameter. It needs to be set for this workspace to run. So now that we've configured that, let's now add in one more published parameter to allow our user to select the coordinate system for the output file. So we're going to do that in a very similar way as before. So right-click on User Parameters and choose Add Parameter. And we're now going to create another choice with alias parameter to control the coordinate system. So let's select choice with alias. This time we'll call it coordinate system. This will again not be optional. And for the prompt, we'll select it to choose coordinate system. And then under configuration, we can open up the browse button. And again, similar to the writer format, we can choose to import the coordinate system list from the existing coordinate systems inside FME. So click on Import Coordinate Systems, and we'll present our users with a choice of a few coordinate systems that make sense for the particular data that they're going to be downloading. So the 3 coordinate systems we're going to add in are the ones that are listed under step 10 on page 3-41. So the first one will be a lat long coordinate system, so LL84. And you can find that from its short name in the list, LL84 here, and check that one to select it. We'll also add in the BCALB-83. So BCALB, and that's the -83 using the NAD83 datum. And then finally, we'll add in the UTM 83-10 coordinate system. So it's just another type of coordinate system for the same general area where these JPEG files would be located. So once you've selected those 3, LL84, BCALB83, and UTM83-10, click OK. You'll see again the display name and values have been pre-populated. And then we'll click OK again. And one more time to create the user parameter. And now let's link this coordinate system parameter to the coordinate system on the generic writer. So if you scroll up in the navigator window, you can find the generic writer here. And down below the destination directory, we can set the coordinate system here. So right-click on the coordinate system parameter and choose Link to User Parameter. And we'll link this one to the coordinate system parameter that we just created. And click OK. And we'll see it's now linked to the coordinate system parameter. And so before we test out this workspace, we're going to do one more configuration change. And we're going to change the output, we're going to unpublish the output location. So find the destination dataset generic, right-click on it, and choose Delete. Since we're going to be running this through the data download service, it doesn't matter, so it's going to be overwritten anyway. There's no point in letting our users be able to select where the output's going. So when you finish that, you can save your workspace. And let's publish up to FME server. So we'll go to File, Publish to FME server, same connection credentials. I'm going to call this one Exercise 3D. Again, don't upload any data files for this. We're going to be using the resources. Click Next. And we'll see this time around the data download service is highlighted in red. When you see this, it indicates that there is some property inside here that needs to be set before this workspace can be properly run under this service. So let's take a look at what property needs to be changed in here. So click the Edit button under Properties. And we'll see the output datasets to include is now blank. So right now, if we were to run this through the data download service, it wouldn't know which files to take to include in the zip file because it doesn't know which writer to look at. So the reason this is unset now is because we deleted our JPEG writer before, and we've added in a brand new writer. So FME's lost the connection between the output dataset in the workspace and the output dataset to include in the zip file. So we can set this up again. So click the Browse button, and we'll select the generic writer. So any output that's created by the generic writer is going to be included in the zip file that gets downloaded when this is run on the server. So we'll click OK, and then we'll choose to publish this workspace up to the server again. So now let's run this up on FME server and make sure the parameters that we just created are working as expected. So open up the server web user interface, and we'll go into repositories. We'll open up the training repository and find the exercise you just published. So in my case, it's exercise 3D. Under data download, let's click configure. And we'll see a list of all the published parameters that we've created. So for the source, we'll choose browse as usual and select the from the TIFF files in the orthophotos directory. So I'm going to select all 4 again here. And then image resolution, I can set that. That just sets the transformer. And then we'll see the 2 published parameters that we created using the choice with alias type. So we can choose ER mapper as our output format. We can choose GeoTIFF or JPEG. So I'm going to go with a ER mapper ECW file this time. So this tells the generic writer to create an ECW file instead of a JPEG. And then under choose coordinate system, I can decide which coordinate system I'd like the output to be in when it's made available to me. So FME is going to reproject into the coordinate system that I choose here, and then I can run the workspace with these new settings and see what I get back. You should see translation successful with 1 feature written, and the data download URL, click that to download my zip file. And inside here, I should now see it created an ECW file instead of the JPEG files that were being created before. So this is because we've configured it the workspace with a brand new writer that can create any type of format that we choose instead of tying it down to one specific format. All right. So that's everything for the data download for now. So we've allowed our users even more control over exactly what type of output's being created. So the generic writer in this case is extremely powerful because it can allow for this kind of flexibility so users can choose whatever type of format they would like to see any output downloaded as. Okay, so we're on page 3-44 in the training manual now. So we're going to look at some more options to allow for even greater flexibility using the data download service and FME server. So spatial data is often organized into different layers, which can also be called groups, classes, categories, feature types, or tables, depending on the kinds of formats that you work with. So another way to provide additional flexibility within a workspace is by allowing a user to select which layers they're interested in. So the simplest way to do this is by publishing the feature types to read parameter within the workspace. This will provide the user with a list of all the feature types or layers that exist inside the workspace and let them decide which they would like to download. So the screenshot on this page shows the publishing dialog for the feature types to read. You can see here it just provides the users with a list of all the layers that might exist inside the source dataset in the workspace. You'll notice here there's an option to use an alternate display name. So it's very similar to the choice with alias. You can provide a more user-friendly name for some of these layers if maybe your internal datasets have coded values or something like that. So grouped layers. This is an option that allows for grouping the list of available feature types by particular themes. So if you take a look at the example in here, the values here correspond to all the layers that exist in the dataset, and the display names is what the user is presented with on the other end. So you can choose to group specific layers together by giving each of them the same display name. So in this example, if we wanted our users to be able to download anything related to amenities, for example, all in the same, and include them all in the same option, we can give any layers that might be considered amenities the amenities display name, so that when the user selects to download any layers related to amenities, they'll get all three with the same name here. So when a user clicks on amenities from the feature types to read, they'll also end up getting accessible parking, garbage schedules, and food vendors in this example here. So it just allows for a little bit more flexibility and allowing for grouping layers together. So if you have maybe a set of water features, lakes, rivers, and streams, you don't want your users to go in and select lakes, rivers, and streams every time they want all the water features. They could just select water and get all three at once. So we're going to continue on with the workspace we've been building, and we're now going to add in an option and use the feature types to read published parameter and include that as an option for our users. So we're going to do that in exercise 3E, and that's on page 3-46. So we're on page 3-46 in the training manual, and we're going to publish feature types to read and allow our users to download some specific layers as well. So the way we're going to do that inside our workspace is that we're actually going to add in some additional data that they can have access to when they go to download these mosaic raster files. So what we have in our data sets is a Bentley MicroStation design file that contains information about all the roads for the particular area where these orthophotos have been taken. And we want our users to be able to take this roads data and overlay it on top of the raster data sets and get an output that has the raster with the roads kind of embedded on top of them, or stamped on top of the orthophotos. And we want our users to be able to decide which road layers they'd like stamped on their raster data sets. And we're going to do that using the feature types to read option. So let's start working on that. So if you open up your workspace that we've been building up, so the GeoTIFF to generic workspace, we're going to add in a second reader into the workspace itself. So to do that, we'll just go up to Readers from the top menu and choose Add a Reader. The format will be as shown in step 1 on page 3-46. So we'll choose Bentley MicroStation Design, and it's version 8, so V8 in brackets there. And then the data set we're going to choose can be found in the transportation folder inside FME Data. So we'll open up the file browser, go to FME Data 2014, and then the data folder, and we'll go to transportation, and we'll select the roads dgn.dgn file. So click on that file and then choose to open it. And then next, we're going to double check the parameters for this the MicroStation reader. So click on the parameters button. And we want to group our elements by level names instead of level numbers, so we have something a little bit more meaningful when we import the reader feature types. So we'll click OK. So make sure group elements by is set to level names. And then we'll click OK to accept that. And then down at the bottom, make sure the workflow options set to single merged feature type. So as long as you have single merged feature type set, we'll click OK to add in the new reader. And we'll see we'll have a second feature type called all. This will correspond to the DGN reader that we just added into the workspace. So next, what we want to do is modify our workspace. so that these roads features, which are lines coming from the DGN file, are overlaid on top of the raster that we're creating. So I'm just going to expand my workspace here and move some of these transformers around to see them better. Here's my output. So I want to take these road lines and use a transformer to stamp these lines on top of the rasters. So to do that, I'm going to use a transformer called the Vector on Raster Overlayer. So I'll place that into the workspace. Just click anywhere on the canvas and start typing the name. So Vector on Raster Overlayer, and click Enter to drop that into place. So you see here there are two input ports, one for the vector features to be overlaid, and then one for the raster features that we're stamping these vector features onto. So take the output port of the DGN reader and connect that to the vector input port on the Vector on Raster Overlayer. And then we're going to take the connection from the raster mosaicer to our generic writer. We'll just move this over and connect it into the raster input port on the Vector on Raster Overlayer. So you can just click on the line and drag it down to connect it over to the raster port. And then finally, we're going to connect the raster output port on this transformer to the input port on our generic writer. So that's all the setup we need for there. The final step for us is to modify or to create a published parameter to allow our users to select which road layers or which types of roads they want stamped into their rasters. So we're going to do that by publishing the feature types to read parameter on the DGN reader. So from the navigator window, find the roads DGN reader, click to expand it, and then look under parameters and move down to the very bottom. You'll see under advanced, let's expand that, and keep on going down to the very bottom of the advanced options, and you'll see feature types to read. You'll notice this has been published by default, so it already exists. So that makes things a little bit easier for us. So from in here, just right-click on the parameter, and we're going to go inside and we're going to edit this parameter definition to make sure it matches exactly what we want. So under Feature Types to Read, which is already published, right-click and choose Edit User Parameter Definition. So you'll see this opens up the dialog for configuring this type of parameter. You'll see it's pretty different from the other modify parameters dialogs that we've worked with. So first up here we have a list of all the layers that exist inside the dataset. So we want to import this list to allow our users to select from the list of options. So under Feature Type List, we're going to set this to a fixed list. So check the fixed list option here. And then under the List button here, we want to import the list of feature types or the list of layers that exist in our DGN file. So click on the drop-down next to List, and we'll choose to Add from Current Dataset. So what this is going to do is it's going to tell FME to scan the DGN file and find a list of all the layers that exist, and then we can choose which ones we want to import for this published parameter. So make sure you select all the layers. So you can check them individually or choose the Select All option. So click OK to import those layers. And now we have a list of every type of road layer that exists in our DGN file. So next we want to create some grouped layers. We don't want our users to have, say, 7 different choices. We want to make the list a little bit more manageable. So we're going to do that. We're going to group these layers together using the option for using an alternate display name. So under Used Alternate Display Name, click that little box next to it, and we'll see now this dialog changes to have feature types and display names. So the display name is what the user is going to be presented with, and the feature type is the value that's going to be passed in the background. So it's very similar to the choice with alias parameters that we've worked with before. So in this case, we want our user to have 3 different options to select from to use to select the road layers. So they'll have the option to select arterial roads, collector roads, and then everything else is going to be labeled as a secondary road. And to do that, we'll just give them all the same display name. So starting at the feature type called non-city, we'll call the display name secondary. And we'll set everything below non-city to secondary as well. So under other, you can type secondary. You'll see the list comes pre-populated with all the other display names, so it makes it a little bit easier to select them. So when you're done, your feature type list should look something like this. You'll have a list of 7 different feature types and 3 unique display names on the other side. So when you finish setting that up, click OK to accept those changes to the parameter. And now we're going to use the prompt and run option to test out this parameter that we just created. So click on the green arrow with the question mark, prompt and run. And we'll see here at the very bottom, we have our feature types to read option. So here, if you click the browse button, you notice we're presented with 3 different options instead of the 7 that actually exist. So we can choose from arterial, collector, or secondary. And if a user was to select the secondary option, it would get, or that user would end up getting all the layers that have that secondary display name. So non-city, other, private, residential, and then secondary as well. So that's working as expected. So before we publish this workspace up to FME server, let's go into the published parameters and clean those up a little bit. We've got a couple, or at least one extra one in here. So you see here, we have the source dataset DGN v8. We don't need our users to be able to change the source DGN file. It's always going to be set to this roads DGN. So just right-click and choose delete to remove that as a published parameter. So your published parameter list should only have 5 options in it now. So we can save the workspace as it is. And let's publish up to FME server now. So we'll publish the usual way, go to File, Publish to Server, same connection information, and we'll publish into the training repository. And I'm going to call this exercise 3E. You'll see here, upload data files is set to 1 file. Let's double check inside that and see what it looks like. So click on the Select Files button from in here. And we'll see none of the TIFFs are being uploaded, which is good because we can set those from the resources. And this is set up to upload the DGN file that we just added as a DGN reader. So that's exactly what we want. Since this is not going to be, since the source dataset parameter for the DGN reader is no longer published, we need to make sure that the DGN file is up on the server and available to this workspace. So we can do that by uploading when we go to publish this workspace. So this DGN file is going to be copied into the repository, the training repository, and it will be available to this exercise 3E workspace only. So this workspace will know to find the DGN file in the repository folder on the server. So when that's set up properly, click OK. We'll click OK again here. This just is a dialog to verify that these TIFF files are going to be available up on the server. Since we're going to be setting them to the resources, that's fine. We can just ignore this for now. So click OK on this option. And then we'll click Next to go to the next page in the wizard. Make sure you're registered with the data download service, and then we'll choose Publish to publish this up to FME server. So now let's open up the web user interface again and test this out. So I'll go back to repositories. And then I'm going to open up the training repository and click on exercise 3E that I just published. And under data download, I'll choose configure. Go through the usual steps here. For the source geotiff files, I'm going to use browse, find it under data, orthophotos. I'll just select all 4. Image resolution, I'll set that to 25. Output format, I can set that to anything. I'm going to choose JPEG so I can view that easily. Output coordinate system, I'll choose WGS84 this time. And then feature types to read. This is the parameter that we just created. So if you click in the dialog to select, you can choose from the list of feature types. So I want to read in only secondary roads, but I can also choose collector as well. So I can choose as many different options as I want from in here. So I'm going to read in all the secondary and collector roads from the DGN file and have those stamped onto the TIFF file or onto the JPEG file that's getting created. So once I've made my selections, I'm going to run the workspace. So that might take a second just to read everything in. So under the data download URL, I can now download that zip file. If I take a look inside of it, I can find my AirPhoto mosaic file. And I chose a very bad resolution for this, but if you look closely, you can see some of these crisscross patterns which weren't there before. So these are the roads that have been stamped into the JPEG file. So they've been stamped onto the raster file and have been returned as part of my mosaic. And I'll just show you one more interesting thing inside here. If I choose to take a look at the job history now, you remember that I'd selected that secondary option, which is a grouped layer. So if I take a look inside here and I check the request data for this particular job, I take a look at the feature types to read parameter, you'll see instead of it submitting secondary and collector, in the background it actually submitted all of the different layers that corresponded to secondary. So choosing secondary from the display list simply was a shortcut to selecting all 5 of these layers themselves. So the value submitted in the background to FME itself was actually the full list of all the secondary layers that exist. All right. So that's everything for adding feature types to read option to add additional flexibility to a workspace that's been registered with the data download service in FME server. So let's take a look at yet another way to add even more flexibility to these workflows. So besides allowing a user to limit the data returned to them from a self-serve application, some other methods for data selection inside FME include things like selection using a rectangular bounding box. So that would be a search envelope. You can allow selection based on an existing area, so something like a regional boundary. So if you want your users to be able to say, I'd only like data for the province of British Columbia in Canada, you can let them choose that, and only the data in that particular provincial boundary would be returned. Or you can allow your users to draw an area of interest themselves. So this would be called an ad hoc area of interest. So we're going to take a look at these different ways of setting this type of area of interest using FME. So for the bounding box, this is the simple rectangular area of interest or search envelope. So all readers inside FME have a set of parameters to define the bounding box of the data that's being read. This is the most efficient way of selecting an area of interest because instead of reading all the data in first and then clipping it to a specific smaller area, FME can simply read only the data that it needs. So publishing the search envelope parameters allows for users to enter in the data extents that they're interested in. So if I open up my existing workspace and I take a look at, say, the GeoTIFF reader, under parameters you'll see these min x, min y, max x, and max y. These correspond to an area of interest or a search envelope. So if I was to set those to a specific area, I would only get GeoTIFF files that are inside that area of interest. So besides parameters for setting the actual bounding box coordinates, these x and y parameters, there are two other related parameters that come with the search envelope. The first one here is the clip to search envelope option. So what this does is it tells FME when this is set to yes, any features that overlap the bounding box will be clipped and the outside part of that discarded. If this is set to no, any feature that overlaps with the bounding box will be returned. So you might get lines that maybe extend outside of the search envelope, and those lines would be included if they're not clipped out. And the other parameter of interest here is the search envelope coordinate system. This allows for the search envelope to be defined using a different coordinate system than the actual data set. So when the workspace is run, FME is going to reproject the coordinate system or the search envelope to a coordinate system that matches the input data set so that they overlap. But this allows you to specify the search envelope using any coordinate system you want. So if it's easier to deal with, say, instead of putting in, say, lat long coordinates, you could put in, say, UTM coordinates instead. So these bounding box parameters are particularly useful when a web mapping application, something like Google Earth, is requesting data. The application can provide the extents of the current map view, and the workspace will only read in features which are within those extents. So if you were doing something like this, you would do that using published parameters. If the search envelope extents are published as parameters with the same names as listed here, so you see this list here, bbox west, east, north, and south. If these are published and your workspace is registered with either the OGC web services or the KML network link service, an application that can read in data from those services, so an application that can read WMS or WFS, or an application that can read a KML network link service, so something like Google Earth, can actually set these published parameters itself. So it'll just set that to the current view extents, which makes querying and updating the data in the current view much more efficient. So that's controlled. Using a parameter, an option, when you go to register with that service, you can choose the view format, and you can tell FME when the bounding box is specified like this, it should set these particular published parameters inside the workspace. So you see with these search envelopes, they only support setting a rectangular area of interest. All you have is a min and max x and y point. So if you wanted to set or use an irregularly shaped area of interest, you will need to use either a clipper transformer or a feature reader transformer to control this. So basically the difference is here, the clipper transformer, the way it works is that you read in the full data set, and you also read in a polygon that contains the area of interest that you'd like to set. So you read in the full data set, and you have, so address points here is the full data set. You push that into the clippy port, and you read in the area of interest as a polygon, and that goes into the clipper port. The clipper can then take that full data set and clip out anything that's outside the area of interest and only return anything inside. The feature reader itself works in kind of a similar way, but instead of having to read all the data in first, what you can do is you read in the data that corresponds to the area of interest, so that polygon, and you send that into the feature reader, and you can set up the feature reader to read directly from the source data set. So inside here it's set to read in all the address points, but you can set that to only read in the points that fall within the area of interest. So it's a slightly more efficient way of reading in a data set because it only reads in the ones that are inside the area of interest. In this case, you're reading in everything and then clipping anything that's not of interest out. So the main issue with using an irregular area of interest is trying to figure out how to define that area. So one option for defining the area is to use an existing area of interest. So this would involve reading in known shapes. So that might be something like postal code boundaries. So it's reading those in from an existing data set, and then using a combination of published parameters and filtering transformers, so things like the tester, to filter out everything except for the area that the user wants. You can then take those areas and pass them into either a clipper or a feature reader transformer to get only the data that's inside that particular area. So that's one option for an irregular area of interest. The other option is using what we call an ad hoc area of interest. So in this case, this is where a user might draw their own area. So it's not something that's predefined. It simply depends on what the user might be interested in seeing. So for this particular case, you'd have to use a different method. You can't simply read it in because the user's creating it when they go to run the workspace. So for this case, it's necessary to create a published parameter that can accept a geometry string, so something like well-known text or maybe XML. They can then read that in and use something like a geometry replacer or a creator transformer to convert that string into an actual polygon. From there, you can send that polygon into a feature reader or into a clipper transformer. So it simply involves using a published parameter to pull in the geometry information, and then something like a creator or a geometry replacer to convert that into an actual polygon. From there, it would work the same way as a pre-existing area of interest. So just a quick recap of what we were talking about just before we were going to get into this exercise. So just before this, we had been looking at some different ways of being able to create published parameters inside workspaces to allow your end users greater control over the kind of data that they were going to be able to download through this download service that we were creating. So we had looked at allowing them to select the layers that they might be interested in downloading. We had adjusted our workspace to have a generic writer inside of it instead of simply a JPEG writer. So the generic writer would let your end users select the format they would like to download their output in. And now we were just looking at some of the different ways of being able to allow your users to select a geographic area of interest. So a few of those options that we had discussed yesterday, I'm just going to flip back a couple pages to the summary on this. We had talked about using a simple rectangular bounding box. So that involved using the minimum XY and maximum XY parameters from the navigator window. These are available on any reader inside FME. So this allows you just to select a rectangular area and tell the reader only to talked about using an existing area of interest, so something like a regional or municipal boundary, so something like postal code zone. Select only the features that are inside that particular area. And then the last one we talked about was an ad hoc area of interest. So being able to capture input from the user, so you could have your user maybe draw their area of interest on a map and then capture those coordinates and save them as something like well-known text and use a transformer like the creator or the geometry replacer to build up an actual polygon from that set of coordinates, and then use that inside a feature reader or a clipper transformer to select all the features within that particular area of interest. So in exercise 3F here, we're going to look at adjusting the data download workspace that we've been building to allow our users to select the data that they'd like to download based on a geographic area of interest. So in this particular case, we're going to use the second option for selecting an area of interest, which is to use an existing boundary. So in this case, we're going to be taking a data set that contains neighborhood boundaries for the city of Vancouver, and we're going to pull that into our workspace and allow our users to select the neighborhood they would like to download their raster data for. So with that, let's get started on this exercise, and we'll just work on building up this workspace a bit more. So we're on page 3-55 if you're following along. And we can start up with the workspace that we'd left off with yesterday. So if you're still working with your EC2 instances, it should be up there somewhere, so you could just open up the workspace you had. If you need to start off with the starting workspace, you can find that at the path specified at the top of the exercise. So that would be on the C drive in these machines. So if you go under Favorites to FME Data 2014, you can take a look inside the Workspaces folder. This will be inside the Server Training folder here. And just look for Exercise 3F Begin. So that'll be your starting workspace if you'd like to start with a clean workspace. So once you have the workspace from yesterday open up in Workbench, we're going to start modifying it. So the first thing we want to do is add a reader to bring in the information containing the polygons that show the outlines of the Vancouver neighborhoods. So the neighborhoods that we have are stored as a KML file. So we're going to add a KML reader into our workspace for this. So inside Workbench, go to the Readers menu, and we'll set Add Reader. So for the reader format, we'll put in Google Earth KML, or you can just type KML to search for it. And then the data set will be at this path in the FME Data 2014 folder. So we'll click the File Browse button, can skip down to Favorites. So FME Data 2014, we'll go into the Data directory. And this is inside Boundaries. And we're going to open up the Vancouver Neighborhoods.kml file. So open that up. Down at the bottom under Workflow Options, we want to select individual feature types this time. There's only one feature type, there's only one layer inside this KML that we're actually interested in importing, so we're just going to import that individual one. So when you've set individual feature types under the Workflow Options, click OK to add in the reader. Okay, you'll get the dialog here to select the feature types you'd like to import from the file. Check the box at the bottom to deselect everything. And inside here, the only one that we're interested in is the one called Neighborhoods. So check Neighborhoods and leave everything else unchecked. And we'll click OK to add this into the workspace. All right. So the next step here, because this is coming from a KML file, this particular data set is going to be in a different coordinate system than the raster data sets that we were reading in. So our raster files are in a UTM coordinate system, and the KML file is in a lat-long coordinate system. So we're going to need to reproject these features into the same coordinate space as the raster files that we're reading in, so that we can get them to overlap so we can clip them to the right shapes for these neighborhoods. So what we want to do here is we're going to use a transformer to do this for us. So we have a transformer called the CS Map Reprojector that's going to let us reproject from the lat-long coordinate system into the same UTM coordinate system as these raster files that we're dealing with already. So to add in that transformer, just click on the feature type that you've just added in and type in the name. So it's the CS map reprojector. Okay, and then let's double click on the transformer and we'll set up the reprojection. So for the source coordinate system, we can leave that at read from feature. The KML file knows its own coordinate system, so that can be set automatically by FME when we run this workspace. So we can leave that as it is. So what we need to set is the destination coordinate system, and we want this to be in the same coordinate system as our GeoTIFF files that we're reading in. So the coordinate system in this case is UTM-83, so we'll just type that in, UTM-83-10. When you see that in the list, just select it. And that's everything we're going to do for this. So we're just going to reproject from the lat-long into a UTM coordinate system. All right, so the next step here is we want our users to have an option to be able to select the neighborhood that they're interested in downloading this raster data for. So we need to add another published parameter to this workspace to let our users select which one they're interested in. So the parameter that we're going to add here, we're going to add in a choice parameter so our users can select from a list of choices and they can select the neighborhood they want to download. So let's add in the parameter now. So in the navigator window, just scroll down and find the list of user parameters. Right-click on user parameters and choose Add a parameter. For type, we're going to set this to a choice type. Name, we'll call this area of interest. This will be published, so leave that checked. And it will not be optional, so we'll uncheck that. For the prompt, we'll just say select neighborhood. And then for configuration, we're going to add in a list of all the neighborhoods that are included in this data set, this KML file. So click on the three-dot button next to the configuration to edit the choice list. So we could type this in manually if we happen to know all the neighborhoods that existed in that data set, but we also have this option to import them. So click on the import button, and we're going to import this list of neighborhoods directly from the KML file itself. So this will save us some time, and it'll make sure we capture every unique value that exists in there. So for the reader format, select KML. And for the dataset, we'll select the Vancouver Neighborhoods KML file that we've been dealing with. So let's open the file browser and select vancouverneighborhoods.kml. When you found that, click Open. And then we'll click Next to continue on with the import wizard. So here it scans the dataset to see all the different feature types that exist. So from this feature type list, we only want to import information from our neighborhoods feature type. So check neighborhoods here. And we'll click Next to move on. So what's happening here, we have a list of all the attributes that exist inside this neighborhoods feature type. So what we can do here is if we select any one of these attributes, this wizard's going to scan that particular attribute and find every unique value that exists in the dataset. So in this case, we want to scan for neighborhood names. So select the neighborhood name attribute from here. When you have that highlighted, click Next, and this will scan the features. So it says it found 9 features and 6 unique attribute values within those 9 features that it scanned. So from there, we can click Import to bring in those neighborhood names into our choice list. So you should have a list of 6 different neighborhoods in the area of Vancouver. So when that's done, we can click OK, and then OK again to create this user parameter. So the final step in this workspace will be to take this information. So after our user has selected their neighborhood, we want to take that neighborhood that they chose and filter out our neighborhood's dataset and only grab the polygon that corresponds to the neighborhood that they chose. So we're going to do this using a tester transformer. So let's add a tester into our workspace and we'll connect it up to the CS map reprojector. So if I just highlight the reprojector and add in the tester here, it'll drop into place and connect automatically. And now let's set up our test. So click on the cogwheel here, the parameters button, and we'll adjust our tester parameters. So for this test, we want to check the neighborhood name that comes from the attribute coming from the features from our reader. So for left value, just double click. We'll click the drop down arrow. For attribute value, find neighborhood name. Next, for the operator, we just want to set that to equal, so just click on that once. And then for the right value, we want to test where the attribute value of the neighborhood name matches the parameter value that our user selected. So for the right value, we want to set this to the published parameter for their area of interest. So double click in the right value, then we'll click on the drop down arrow. And down here under user parameters, we can find the area of interest parameter that we just created. So when you found that, click on that. And we now have a test that will match an attribute value with a published parameter that a user can select. So we can click OK on here to accept these tester changes. And we'll move on to our next step. So the final step in this workspace, now that we've been able to grab the polygon corresponding to the neighborhood that our user's interested in, we want to clip our raster features to the outline of that neighborhood polygon. So we're going to do that using a clipper transformer here. So just drop in a clipper transformer into the workspace. So I'll just start typing clipper. So you want to connect the passed port from the tester to the clipper port of the clipper. And then we'll connect the raster output port from our vector on raster overlayer into the clippy port of the clipper. So here the clipper is the outline of the polygon, and the clippy is the feature that we want to chop to that outline size. And then we'll take the inside port from the clipper and connect that to our generic writer in our workspace. So at this stage, your workspace should look something like this. So this will do the clipping. So the logic inside here is now complete. So the last thing we want to do here is clean up our published parameters again. You'll see if we take a look at the list, we've got the KML source dataset that's been automatically published. We don't need our users to be able to set the KML file. So just right-click on the source dataset OGC KML parameter, and we'll choose to delete that one. And let's save our workspace now. And we can run it to test to make sure everything is working correctly. So use the prompt and run button to run this workspace. And we'll set this up. So our source geotiff files, we can select a few from our folder. Image resolution, I'm going to make that a little bit higher. We'll give that 10. Just pick any one of the three formats. I'll go with JPEG again because it's easy to view. I'll choose any of the coordinate systems. Under feature types to read, maybe I'll do arterial roads. And then the neighborhood. So this is the choice parameter that we just added into our workspace. So we can select the neighborhood from here. So maybe I want to download only the raster for the Kitsilano area in Vancouver. So I can click OK to run the workspace. This will just take a minute. So now it's also reading in the neighborhood polygons, filtering out the one that I was interested in and clipping to that. You may see the unexpected input dialog open up. The reason for this is because we only selected one of the feature types from our KML reader, and there were a couple other features in some of the other feature types there, and this is just a little warning to make sure that this was an intentional change, which it was. So this is okay, it's safe to ignore. We can see here, if we take a look at our workspace, we had those 6 neighborhoods read in. The tester filtered all but one out, clipped them out, and then wrote a single raster file to our generic writer. So let's take a look at the output. So I'll just right-click on the writer feature type and choose Open Containing Folder. And this will be my Airphoto Mosaic JPEG. That was created this morning, so that looks good. And here it is. So you can see I've got my raster here. It's been clipped to the shape of the Kitsilano neighborhood in Vancouver. And you can even see this red line here. This corresponds to the arterial roads that I decided to overlay on my raster. So I was able to customize exactly what's coming out of this based on those parameters from my workspace. So that's good. Everything is working correctly. So our final step here will be to publish this workspace up to FME server. So with that, we'll go to the File menu and we'll choose Publish to FME server. Again, we can use the same connection information as we were using yesterday. Host name localhost and username password admin. And I'm going to call this one exercise 3F this time. Under upload data files, I've got 21 files that are trying to be uploaded, so that's not what I want here. So I'm going to go in to select files and make sure only the 2 that I actually want uploaded are selected. So I'm going to uncheck all of these and make sure I have the Vancouver Neighborhoods KML file checked, and look for my roads DGN file as well. So those are the only 2 files that you actually need to upload with this workspace. Everything else, we're going to set these TIFFs to come from the resources that we published to our server yesterday. So click OK. You can safely dismiss the next dialog as well. We'll click Next to continue on with the publishing. Make sure you're registered with the data download service, and then we can publish to FME server. And with that, let's test this in the web interface. So open up your web browser, and we can go to the server main page. If you don't have that open anymore, it's simply localhost /FME server. And log in with your admin account if it's not logged in already. And we'll head over to repositories, and we'll find that workspace we just published. So it's in our training repository. And we'll look for exercise 3F. Under data download, click configure. And let's test this out one more time. So for the source GeoTIFF files, I'm going to use the Browse tab and find this under my data orthophotos. And I'll just select all 4 in this case. Image resolution, I'll leave that at about 10. I'll go with JPEG for my format again. I'll go with maybe WGS84 for my coordinate system. And I'll also choose collector roads. And for my neighborhood, I'm going to select West End this time just to change it up a bit. When you've selected that, you can choose to run the workspace. And there we go, should get a successful translation, 1 feature written. You download the zip file here and open this up. I've got my air photo mosaic JPEG file. And I can see here I've got my output with my roads overlaid and clipped to a different neighborhood shape in this case. So this corresponds to the West End in Vancouver. So just a quick check out there, just to make sure everyone's keeping up okay. Can you just let me know if you were able to get that download working correctly and you're seeing the output as expected? Just please raise your hand. Oh, okay, so that looks good. All right, thank you. So if you do have any questions as we're going along or you've fallen a bit behind, just feel free to send us a question through the questions panel. We're happy to help you out and get you back on track. We don't want you to miss out on too much during this course. So if you ever get behind or any of that, or if you have any questions about anything that we're covering, please do feel free to ask us a question at any point. Okay, so with that, I'm just going to continue on here and just finish off this chapter. So we're on page 3-60 if you're following along. So we'll just take a quick look at some of the other services available for self-serve data transformation. So we've looked at the job submitter service that simply writes data to where the workspace is pointing. We've seen the data download service that returns a link to download the data as a zip file. And we've also seen the data streaming service, which returns the data itself streamed directly back to the client. So we saw the data streaming service in action yesterday with that workspace that we'd created that was building an HTML file and streaming that back to the browser. So just getting into a little bit more detail on the data streaming service itself here. Essentially, following a URL that points to this type of a service would cause the output data to be downloaded automatically and opened in the application associated with its file type. So only file or folder-based datasets can actually be streamed. And if an output format returns more than one file, say you build up a workspace that, say, writes out to shape, which creates, since a shape dataset is made up of several different types of files, you've got the SHP, and there's a .dbf usually associated, sometimes a .prj, that are all part of the same dataset or the same data file, the same shape file. In this case, since there's more than one file that comes back, these would be returned in a zip file if you were to use the data streaming service with a workspace that wrote out to this particular format. Some of the common formats for the data streaming service include things like RSS, GeoJSON, KML, HTML, which we've seen, and JSON. So I've used JSON with the data streaming service before myself when I'm building up web applications. So what I can do in that web application is hit a URL that runs a workspace that returns JSON, and then I can consume that JSON directly in my web application. So that's one kind of use case for that type of data streaming service. So the other types of services that we've kind of briefly mentioned but haven't really talked about too much include the KML network link service. So this is a very specialized service that is created only for use in a KML browser. So that would be something like Google Earth. Only workspaces that write out to the KML format can be used with this service. The output returned by this service would be a simple KMZ file that only contains a network link to the data streaming service for the associated workspace. So what happens then is when that KMZ file is opened up in Google Earth itself will follow the link to the data streaming service, which will in turn run a workspace on FME server, and then that data is streamed directly back to Google Earth. And then Google Earth can display that directly in its own interface. Then Google Earth itself will actually rerun that translation at a regular interval, depending on the refresh rate that is set for that network link file. So that's a good way to create a data set and open it in Google Earth and have it refreshed regularly so you always know that you have the latest copy of the data itself up there. So this next workspace, or this next exercise here, just gets into another example dealing with the data streaming service. We've actually tried that out a little bit with another workspace that we built. So I think I might just skip over this. This is essentially the same as that workspace we built yesterday that was creating HTML. The difference here is that we're actually using a workspace that writes out to JPEG. So when the JPEG is streamed back to the browser, the raster file itself will be opened up directly inside the browser. So if you wanted to do this, you can come back and try this out on your own time later today. But it's essentially just going back into this workspace, replacing the generic writer with the JPEG writer again, and registering this with the data streaming service, and getting that output that we've been seeing already directly in the browser.